Okay, 11.2, we're looking at matrices. Matrices are really cool because we can do a lot of cool stuff with them. So a matrix is going to be classified by its dimension, which is the number of rows and columns that it contains. So rows are across, columns are down. Okay, so let's keep that across times down. So A, D, so across comes before down, A comes before D in the alphabet. Okay, so if I'm trying to find the dimensions of a matrix, this matrix here goes 2 across, 3 down. Okay, so across times down. A square matrix has the same number of rows and columns, so the dimension would be n times n. So for example 1, okay, this would be 1, 2, 3 across, 1, 2 down. So that would be a 3 by 2 matrix. This is 1, 2, 3, 4 across, and 1 down, so 4 by 1. And then this is 1 across, and 1, 2, 3, 4, 5 down, so 1 by 5. Matrix operations. So in order to find the sum or difference, the dimensions of the matrices have to match first. So that is the first thing you're going to look at is, are these the same? Okay, so this is a 2 by 2 and a 2 by 2. So we can go ahead and do that. And then you're just adding the corresponding values. So this is, sorry about that. This is row 1, column 1, there we go, or across 1, down 1. And then row 1, column 1 here. So 5 plus -4 would give me +1. And then -6 plus 6 would give me 0. And then 8 plus 8 would give me 16. And 9 plus -3 would give me 6. Okay, so the same row column for the two matrices, you would add or subtract. Another example, okay, find A plus B if A is this matrix and B is this matrix. This is a 2 by 2, and this is a 2 by 3. So you can't, okay, so this is a no solution, or we could call this a dimension mismatch. Okay, let's do an example with subtraction. So here we have a -5 minus -3. Okay, that would give us a -2. Then we would have a 6 minus 2 would give us 4. Then 2 minus 5 would give us -3. And then 4 minus -8 would give us plus and 12. So we'd have a new matrix of -2, 4, -3, 12. All right, now addition and subtraction is a lot easier by hand, but you can also do this in your calculator. So we are going to take a look at that in a minute. If you are adding a matrix to itself, okay, each element is twice as large as the corresponding element. So if I'm adding these two matrices here, 2 plus 2 is 4, 5 plus 5 is 10, and so on. So you could just say that this is 2 times each value in the matrix. In that expression, the 2 in front is called a scalar. Okay, so the scalar, it just means it's almost like distribution. So you just would distribute the scalar to each value in the matrix. So for this example here, it would be 5 times 2. All right, I wrote the 5 there. 5 times 2 would give us a 10. 5 times -3 would be -15. 5 times 0 would be 0. And 5 times 4 would be 20. Okay, so it's almost like you're just distributing the scalar to each value. Well, it is like you are distributing to each value in the matrix. Multiplication for matrices. Now this does get more complicated. So this one I'm okay with you doing in your calculator. So well, let's first go through it and then I'll show you how. So the product of, okay, AB of an M times N matrix A and an N times K matrix B is MK matrix. So, for example, here we have the matrix A is a 2 by 3 matrix, and this is a 3 by 2 matrix. That is okay. You can multiply them if they're not the same dimension. The answer is going to be a 2 by 2 matrix. So it is going to be the first value, okay, in the dimension for the first one, second value of the dimension in the second one. So the answer is a 2 by 2 matrix. Here is how you're going to do this by hand. Okay, take a look here. So for this one, it is worked out for you, but you're going to go -3 times -6. So row 1, column 1, row 1, column 1, you're going to multiply those together. That gives you positive 18. Then row 2, column 1, row 1, column 2. By row 1, row 2, column 1, 4 times 2 gives you 8. Then row 1, column 3, by row 3, column 1, 2 times 3 would give you 6, and then you add those together, and that gives you 32. Okay, then you do row 1 times column 2. So -3 times 4, -12, 4 times 3, 12, 2 times -2, -4. You add those together, you get -4. Then row 2 times column 1, 5 times -6, -30, 0 times 2, 0, 4 times 3, 18. -30 plus 18, 12, gives you -18. And then the very last thing you do is the row 2 times column 2. So 5 times 4 would give you 20, 0 times 3 is 0, 4 times -2, -8, 20 minus 8 gives you 12. So then this would be row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. So you would have your 2 by 2 matrix look like so. 32, -4, -18, 12. It takes a while. It also takes a while to put this in your calculator. So you really only want to do this when these are going to be longer problems. All right, so your matrix is going to be right here. So 1, 2, 3, 4 down. Okay, so row 4, column 1 here in the yellow. So it is second, x to the -1 to get your matrix. All right, now here's the names of your matrices. So this would just be to pull the matrices to do operations. Scroll over, that's math. This is to do things with the matrices. Scroll over to edit. This is where you're going to edit and enter your matrices. So we're going to go to edit, enter, and we're going to put the dimensions of our first matrix in, which was a 2 by 3. And then we're going to enter these in. So we had a -3, enter, 4, enter, 2, then 5, 0, and 4. So that was our first matrix. So -3, 4, 2, 5, 0, 4. We need to enter our second matrix in. We don't have a back button, so you're going to go back again to second matrix, go over to edit, scroll down to the second one, matrix B, and then enter. And then this is a 3 by 2 matrix, and we're going to enter this in our calculator. -6, 4, then 2, 3, then 3, -2. Okay, we are done putting the matrices in. So go back, second matrix. They're in here. So you have a 2 by 3 and a 3 by 2. Now you want to multiply these. Okay, so let's go to the home screen real quick. So second, quit. We want to grab these matrices. So you're going to go back to the matrix. So second matrix, and then just enter because you want names. This is just the name of matrix A. I want to use matrix A times matrix B. Second matrix, scroll down. I want the name matrix B. and it multiplies them for us. So 32, -4, -18, 12, just like we had. Okay, and we're going to be exploring a lot more operations with matrices in our calculator, but let's look at some more things here. So an augmented matrix is a system of equations written as a matrix, and it's super easy to do. You're just going to write the coefficients. Okay, so you're going to make a matrix. This would be a 2 by 3 matrix here because you have 1, 2, 3 terms. So you're going to put the coefficients of the x's, 3 and -4. Then your coefficients of the y's, 2 and 1. You're going to draw a line where the equal sign would be. And then you have your constants, -5 and 8. And then you close the matrix. So that is your augmented matrix. So it's pretty easy to do the augmented matrix. And then you can go backwards. X is always going to come before Y and write it as a system of equations as well. Subscript notation, that is just the row and the column. So think about like an Excel spreadsheet. You have row 1, column 1. So like if I said I wanted well, let's see here, 30, we'll go 32. That means I want row 3, column 2, which means row 3, 1, 2, 3. And then column 2, where does that meet up? Right here. So whatever number is in that place. That is your subscript notation to find where certain values in a larger matrix are. And that's where we're going to stop with matrices for today. We'll continue with that, doing some more operations with them in our 11.3 lesson.